Alright, welcome back. Now part 2 of design pattern called parallelization. So we looked into or how to build 3 different tools or 3 different services. One is annual report, second one is earning calls, and third one is company presentation. Although company presentation was not implemented, I just left it as a placeholder. Idea is just to show you that this can be implemented in a similar manner, but here the challenge was that it needs some different kind of mechanism to bring the data into the system, because it's not that straightforward. So I have implemented right now 2 tools which are like the data is already there in the ChromaDB. Now I am going to convert those use those implementations and build a tool for agent. Now remember, agent just needs tool. Now first tool is get annual report data. It will pass a ticker and a query. That's what agent will do. Okay, and this function should do what? It should initialize the instance and call search function, pass the ticker and query and top 3. So it get top 3 results. We can do top 5 also, but top 3 is also fine, and we can change it. And if results come status as error, just return this error. Otherwise, relevant pages are extracted and we have a pages, and from the pages I will build the output. So that's what we are building. So like output is annual report this, and then I'll read the pages, I'll put the output. Here is the filing date, metadata, and then here's the text. But here I'm only printing 500 things. So what I can do is this is just to reduce the amount of data which is going to model. So what I can do is I can probably leave it. Only thing is then in this case complete page will go, but in the real applications we should send the complete page. But just to make sure that I'm not running into any overutilization of the tokens, so I'm just restricting it to certain number of characters from the text. So this is my first tool. That's why I have a @tool decorator on this function. Second is get earning call tool. So this is my similar way. I will do the earning call rag, call the search function, and then we have output prepared like this. Let's do that. And then third one is get company presentation. Although company presentation, we know that it will not return anything because I've not implemented it, but we'll just, for the standard purpose or for the demonstration purpose, we will still have this tool. Let agent call it, and we'll see that agent tried calling it, although it did not get any data. So it just use whatever was available in the 10K and 8K report. So okay, so 3 tools are created. Now I register a tool. So this is how I do it. I just come up with list of these tools, okay, and just print it. So here are my 3 tools, okay, and yeah, this one is just to, I think if I put 1,000, we can get a complete description, you know, what is this tool about. So you see, this is how this information goes to tool. Let's say this tool, right? So rack tool. So this is get this one and the description. So we get to know the description, and that is the most important thing for model or for agent, to know which tool it has and what is this tool about. Otherwise model will not know which tool to call and when to call. So it needs a description which gives an idea, you know, this tool can be used for XYZ purpose, and it returns some data which is required probably for agent to take some step to complete the task. So these are the 3 tools. Now I think I already sampled it. I don't need to, but you can check it. If I do it, I think it will say it's already indexed. So let me do that. So I'm trying to download an index, but it should say it's already available. Yes, it says already indexed. Here it also says indexing 1. Okay, found 3 recent. Found, okay, so indexed 2 pages because there were 2 already indexed, but one it found 3 recent one. I think 2 were already indexed, so it did not do that. So successfully indexed 2 pages from one filing. Now let's test this tool. So this is the, now how do I call the tool? I call this tool.invoke and pass this. So earlier when I was testing it, a function which was written as a part of those classes, so which were part of the rag. So I was just directly testing those util or those functions. But now I am having these as a tool, and if I want to invoke it, I need to call invoke function, which internally will call those functions itself, which is I had mentioned. So if you see here, I called get annual report data invoke with the ticker and query, and what happens, it will come here. So this one will go to this function, this tool got called, and it would have called this annual rag search function, which is here. So we have the annual rag, go back, okay, here. So this one, so this is our annual report rag, and it has called this function. Okay, so that's what I wanted to show you there. Okay, go back now to this one. Okay, this is already called. So we got the data. So you see result one is filing date, page number, similarity, consolidated statements of operation, because we are asking what was the Tesla's revenue growth and key financial metrics. So related to that, it got some pages found. Result 2, page number 109, result 3, page 110. So we got one page data from page 129, data from page 109 and 110. So this is the data, and I'm not printing again complete data. Am I printing complete? Okay, one second. Result, yeah, I'm printing the complete data, yes. So that's there. Okay, next test tool, earning one. So let's call that tool. So we get the data again from here. It means data is available in both the tables or both the DBs. And now I will check the timing, because we talked about parallelization. Why we want to do parallelization? Because these all are independent data. Annual data is different from earning calls. Earning data is different from company presentation. So to address a query or complete a task by agent doesn't need to wait for one tool to finish its execution. It can do that in parallel. So we'll demonstrate that one. So first I'm just showing you that if I call these tools, two of these tools in sequence where it is happening, so how much time we get. So let's check that. So we get total sequential time 0.71 seconds. Now here it is fast because it is locally hosted ChromaDB. It is just accessing the local file where both the data is present. Now let's check stats for this. So let's run this one. So this is where it will show you what we have in the annual report DB. We have 225 pages. Earning calls we have 39 pages. Company presentation 0 pages because we did not implement that company presentation. And the sample document metadata looks like this. Okay, so this is the RAG part for parallelization. Now let's do the integration. Now we have done the tools completed. Now part 2 actually is we just have to implement agent, and which is a LangGraph, configure the graph and execute the query. So let's run that in the graph. Come here. Okay, sorry, I think I need to install this one first, LangGraph. So let's install. Okay, now it is installed. LangGraph is the library from LangChain which help us to build agentic application. So that's the one. Now define stock analyst state. I covered already this part in a previous video. Okay, now coming back to the state variable. So I think we discussed that in a previous video. So we need few variables to store the state of the whole application, agentic application. Why? Every node will generate some data, and I need that for a future nodes. So that's what I need to think of first. What do I need to store? For example, I need user query. User will ask a query, I will store in that variable. Then ticker. Ticker means user is asking a question or query for a given company. Which company? So that I will store separately. Then subqueries, and I will ask LLM to break user query into subqueries. Like user will say, okay, tell me the latest revenue reported by Tesla. Now I probably want to look into this data into annual report, into company presentation, or in latest earning call. So I want to look into that in 3 different places. So what I want to do is I want to prepare 3 different queries, and that's what the subqueries information I will store. But all that will be done by LLM. User is not going to give me 3 different queries. User will just send me one straightforward query. And tool results, so when I run those queries against 3 different tools which I showed you, then I will be storing the results there. Then aggregated data means just aggregate the return data into one place as a string and generate a report. So step number 1, so node number 1 here. So because we are now starting the implementation of a workflow, which is a LangGraph workflow. So first step is when a query comes, you break the query or decompose the query. So we say extract the stock symbol stock ticker symbol from the user query, return only ticker. Okay, and second is break down this investment question into 3 focus subqueries: annual report query, earning call query, and presentation query. Okay, and return JSON format like annual report query, query 1, that's 2 and 3. So let's get started. So first, when we run, we will get ticker, and when we get, and for the second one, we will just get 3 queries. So let's run this. Now we get the second node, which is parallel tool execution. Now in this case, what do we want? We want to invoke these tools. So this is a main node which will be executing these tasks in parallel. Okay, because I have not implemented company presentation, so I have not considered that as a task. Otherwise I would have added that as well. So since I have only 2 tools implemented, one is annual report and second one is an earning call, I am only having that added as a task here. So what will happen? First I will take the ticker out of the state variable. Second, I will take the subqueries. Then I will define the tasks. Okay, subqueries, task is very simple: annual report, the tool name and the subquery, earning call, tool name and the subquery, the total tool result. And I will just, you see what I'm doing is I'm just creating a async process here, which means with the max worker 3s, and all these tasks will be submitted together. Now we have only 2 tasks as of now, and all will execute in parallel. Once they are executed, all I'm going to do is I'll keep that data in the tool result variable, which is from the state. So let's run this. Now aggregate results. Now how do I aggregate results? That's like, once we have the data which is in a tool result, I'll just take it and I'll say multi-source financial data, and I just aggregate using some kind of a concatenation. So I just join the data which I got from 2 different tools, annual report and earning call. So I do that. Now if you see all these tools, or both of these tools, what are they doing? They are giving me 3 chunks each. So they'll be like a raw chunks, right? Now I'll be getting total 6 chunks of data for one single query, because the query was broken into 3 queries, and 3 queries will be executed for 3 tools. 2 tools, third one is not implemented, but all these 2 tools will give me 3 chunks each, so total 6 chunks of data I'll get. Now generate investment analysis, which is this node will be responsible for generating the final output. It means once any of all these parallel nodes are executed, I will have this aggregated result node, which is node 3, which will aggregate the data, and the final 4th node which will generate the report or analysis. So which is very simple prompt: you are a senior financial analyst, based on a multi-source financial data below, generate a comprehensive investment analysis report. So we'll pass the question, we pass the ticker. Here is the data, financial data, and I'm restricting it again to 6,000 characters just to avoid overutilization of tokens. And I'm also telling generate the structure report with this structure, like summary, strength, risks, recommendation bias, and all. And then finally I execute it using llm.invoke. So let's run and let's see the results now. And okay, now the last step is graph. I think we have not built the graph, we just build the nodes. So we have to configure everything together. So this last step is just configuration. Add all these nodes: decompose query, parallel execution, aggregate results, and generate analysis. All these functions are listed, and then I will have an edge from start decompose query first. From decompose query, it will go to parallel execution. From parallel execution, it will go to aggregate results. Aggregate results will go to generate analysis and finish. So let's do that. Okay, let's visualize it. Visualize our graph. So you see that parallel execution, right? In the parallel execution, what is happening is in the same function, I am calling that all these 2 tasks in an async manner, like in a parallel way, using a Python thread class. Okay, so I have this thing running in order, Tesla investment analysis. So let's check that. So can you analyze Tesla's financial performance and investment potential? I am considering buying this stock and want to understand if it is a good investment right now. And here I am going to invoke a graph just with a user query. So let's run this. It's saying, okay, query decomposition, extracted ticker. Okay, it made this parallel tool execution, it got data, Earning call, step 3, aggregating results, now generating investment analysis. So it got total data as 3,713 characters, so 2 data sources, analysis report generated. Okay, so let's see the report. So it's saying final investment report is result, whatever we got here. So here is the investment report. Tesla has demonstrated solid revenue growth, profitability, with total revenue reaching approximately $95.3 billion in 2024, up from $94.1 billion in 2023. So strengths, these are the strengths: strong revenue growth, market leadership, diverse revenue streams. Risk profitability concerns: increased competition, regulatory risks, and recommendation or hold, rating 7, rational. While Tesla shows strong growth and potential market leadership, recent profitability challenge and increasing competition warrants a caution approach. Okay, so this is what we got from this one. And second is performance comparison. Okay, this is just a tool to figure out just the difference, to show the difference, that if I would not have implemented this design pattern, which is called parallelization, then I would have implemented or called these tools one at a time or in sequence. Then it just shows you the benefit of, what is the time benefit in terms of savings of whole processing of this query done by the agent. Okay, so these are another widgets which I'm not going to run. I will share this notebook. You can take a look, try it out, play with it, and try different companies. The part which I've not implemented, which is company presentation, you can try to implement it and see that it is useful for some real interesting insights. And I hope you understand this parallelization, the power of parallelization, with very, very real data bringing in from websites like SEC Edgar APIs and real-time analysis on that. Thanks for watching, and see you soon in the future video.